Welcome back to the
Retro Tech Repair Shop.
Yes.
You want me to print that
I
out?
haven't got the teeth, yeah.
Print out a bit of paper, put it in front of you.
Gonna try. Welcome back to the Retro Tech Repair Shop. Today we have one of my childhood favourites with me. It is an MB Electronics computer battleships game. Don't know the condition of this. Gonna unbox it, we'll put some batteries in it, gonna try it out, and then if it's all working we will give it a service, take it apart and make sure it's good for the next 30 years. So hang around, let's find out what goes on.
Oh yeah, so we've got a computer battleship. We have, and here it says, take part in a fierce battle of the high seas with computer technology to pursue and sink your opponent's fleet. Hear the hunting of the sonar, the whistling of the missiles seeking their targets, and the convincing explosion of a direct hit. See the horizon light up with each successful hit, and claim victory with 3 whoops on your opponent's siren. Oh, it also says 2 9-volt F. Let's say that again.
It says what?
It says 2 9-volt 6F 22 batteries required, not included. Alkaline batteries recommended. I'm just doing this now. This is how it works. So we've got this tub. These batteries are not part of it. I'll just put them. Okay. So we have the a tub, which obviously doesn't come with it. I guess I'm assuming that in the original it just comes in a plastic. This stuff just comes in a plastic bag or something. With it looks like an odd amount of ships because we've got 3 of the 4s. We got 2 of the 5s. We've got 2 of the 3s, and we've got 2 of the 2s. We've also got 1, 2, 3, 4 dice for some reason. I don't remember a battleship needing dice, but okay. And also all of the red and white pegs, which is cool. Oh, Jesus Christ, that's a big boy. Okay, let's move the box out of the way. Okay, so I'm assuming that this is the bit that goes in between like that or something. Yeah, that looks about right. Which is kind of cool. Okay, so we've got that. I'm assuming that this is the battery compartment here, this bit that wiggles, so I need to take the thing off to put batteries in it. So, battery cover, lift to open. It's got a little bit of sponge that's starting to turn yellow, I mean orange or whatever. Okay, I'm assuming these Nova batteries go in here. Okay, let's see. Okay, it's making beeping noises. Is this normal? Do you remember? Is this what it usually does?
Yeah, it's the sonar noise.
Okay, so we have the beeping buttons and then there's a fire button. I didn't really load anything into it, so that's not surprising it didn't do anything. So if I just go here and, for example, put, I don't know, A1, and then I'll go onto here, and then put A1. Hey!
I didn't know you could do that. I thought you had to load all the coordinates in one go. So it sounds like it's functioning, doesn't it?
Yeah.
Does the switches all work, the buttons all work in all the positions because all the coordinates?
Okay,
So
well that's...
connections can be very dodgy.
Oh, on this side seems to work.
Good.
Let's try the other side. There's got to be something wrong with this thing, or otherwise.
Could be that the seller just didn't have the batteries to try it, so they sold it as not working, potentially not working.
Yeah, true.
Okay, so it appears that it all seems to work at the moment. You've loaded in a coordinate and it accepted it, and when you fired it scored a hit, so it all looks like it works. I've always wondered why there's two 9-volt batteries inside the battery compartment.
My theory is it's like two different little computers or something, and then they just communicate through like two wires. But then that wouldn't make any sense, would it?
Well, I don't know.
I don't know, let's open it up and see.
I don't know if the batteries are in series or if they're in parallel, or whether they do different jobs within inside the unit. Let's open it up.
How the heck do we open this thing up, hey? Oh, okay, that sounded like I broke it, but no, it's just came off a bit rough. Battery. We all know what a 9-volt battery looks like. Let's work out how would we open this thing up. Would it open at the back? Does the back open up? Is there any screws on the back? I mean, there's little clips on the bottom of this. Seems interesting. Quite stiff little things, aren't they? Oh jeez, that is. This is going to be interesting. So, you don't understand. You don't like it. Your grandkids will love it. Okay. Yeah, it's quite a cute little thing. It's tiny. It's absolutely tiny. So yeah, it's just all in this little bit here, which means that this is just now a boring bit of plastic. Little circuit board's off, but it's held on by something, and yeah. Is it the speaker I need to take out? Do I need to take this speaker out? Is that how it works? There we go, gently just pop that out. Something's holding this in. I don't know what. These little thingies. There we go, now that pops off. Screws were holding it on. There. And then we've got this, which, okay, I was honestly expecting this to be a bit more fancy. Geez, that's a heavy speaker. But expecting it to be a little bit more fancy than two chips.
He's managed to dismantle it absolutely fine. I'm going to have a closer look at the circuit board. It's very grubby. Clean up all these connectors, have a general look around the state of the soldering and that as well. We know that it seems to work okay at the moment, so we'll just try and rectify any defects that we find. We'll move over to the other bench and we'll have a close look at this board. Okay, we've come across to the other bench now and have a look at this circuit board. Let's have a quick review of how this works. For firing the coordinates and for programming it, we're making an electrical connection between these points and these rails. So when you press one of these buttons down, they're spring loaded and they short out between this side and this side, or the other button, that side and that side. So you move them along to these different positions and press them and make a contact. The problem that can occur with these are that these contacts over the years get very dirty and they don't make a good electrical connection between these points, or the fire button between these points over here. So what we'll do is we'll give this a good clean up. We'll clean out the switch as well. Electrically on here we have a couple of chips made in Singapore. and these will be the ones that store the function, the program, etc. on them. We have a few electrolytic capacitors. Again, over time capacitors can leak, they can become ineffective. That's always a weak point with old electronics, is the capacitors. We have some diodes here, etc. We have some ceramic type capacitors here. These are just links on the board. We have the red LED, or the LED for the fire, for the hit. A couple of switches, the speaker, and the power supply coming in down here. Now, I wondered why we had two. I've always wondered this. Let's have a little look. We've got the two battery connections coming in, and they're actually, looking at these tracks, they're actually in parallel. So we're only getting 9 volts onto the board, but we're getting 2 batteries. So it does enable you, I suppose, to change a battery. They probably needed that for the extra power, rather than just using one battery. I suppose you could try just putting one battery in and playing the game, see if there's any difference. Gonna have a look around the circuit board again. Technology back in the 80s. This would have been hand soldered pretty much, and some of these you can get dry joints on them. So we're just going to go around and dab any of these connections that we're not happy with the soldering iron, and go from there. Basically give it a good clean. So I'll bring in my child labour to do that.
Get a little pool in it. Oh geez, that smells very strongly of chemicals. And then just give them a little wipe down. There we go, I've covered the entire thing in the IPA stuff. Even the stuff that doesn't really need to be covered in it. Just done it anyway.
Alright, what I like to do as well
Spray some
is to
on
get
there.
into these contacts, so I normally do that more directly.
So you could just spray it.
Just spray it, try and get it penetrating in there, just spray it on top, and then just I'll do it again. Okay, so what you want to do is move the board aside, it will dry itself. Move this in, and again use the cotton wool bud or whatever, and really work at these contacts. You see they're quite, on these edges where they make the connections, you see they're sort of black.
Yeah.
That's where you get all your poor connections from.
I've just got an alcohol brush. Yeah.
Why do you like Android rather than Apple?
More secure.
Mm-hmm.
It isn't as locked down, which means you can do more things with it. The newest features come out on it first, all that stuff. Like facial recognition was around in 2012 or something. Meanwhile, the new iPhones have only just got it like a year or two ago.
Okay, now it's had a general clean up. I'm going to do is plug the batteries back in and hopefully demonstrate straight onto the circuit board how this works. Okay, the batteries are in. That's the on-off switch, so switch that one on. Okay, so when at the moment we're in the go position. The fire button is between those two there, and is the coordinates. So if I short out between the rail and a set of coordinates, so we'll go 1 and A, and then do the fire. Wonderful, right, so I'm going to switch it into the load position, to lower the coordinate in, switch it on, So I'm in the load mode now. So I'm going to load in, let's go on the M1, so J10, hold that on there, J10, and now do you press the fire to load it in? Okay, put it into run, into the go mode, and the opposition is going to select that coordinate, so that will be J10 and fire. Okay, so that's basically how the unit works. You start by entering the coordinates. The aircraft carrier has 5 coordinates to add. The battleship I think is 4, etc, etc. So when you've entered that amount of instructions into the chip, it will then confirm that you've entered all those coordinates and it's happy, and when both sides have got all their coordinates in place, you can then play the game. As I said previously, some of these soldering connections don't look so good. There's some of these haven't got much solder in them. These can eventually lead to sort of cracking and a poor contact. So what I'm going to do, basically I'm going to do a reflow on these. The battery connections aren't very good here as well. Let's do that. Okay, let's reassemble you and try you out.
Goes there, and then this whole assembly here somehow slides in and then pops down or something like that. There we go. That didn't sound like anything, boys. And then these lid boy thingies just go on here. Okay, and turn it on. Put it into load mode on A1.
And fire, I think. Yeah.
Select, and then go into go mode, and then just put A1 fire, and the light should flash, and it's all good. Okay, that's all good.
Let's do that again. So let's clear the memory. Okay. In the load position, we're going to load A1 on this one. Hopefully that's the instructions gone into the chip. On this side we're going to load C3. Okay, we go to the go position. If we do A1, yeah, I've cleared all the coordinates. Excellent.
Nice. So it works.
Okay, so we've had an initial look at this unit. We've taken it apart, found out a little bit about how it works, and we've rectified a few little soldering problems on the board. Got some better connections now with these coordinates and the entry. We've loaded an instruction in, and we've then fired on that, so it knew it had one coordinate. Once that coordinate was hit, it then did the alarm to say you've won the game. So the whole unit seems to be functioning just fine. So that concludes this episode. Thank you for watching, and we'll see you next time.